right, you guys, I want to continue with where we left off about rotating and reflecting and translating. And just this particular lesson is about looking at a coordinate rule. In other words, a summary rule for a reflection or for a translation or for a rotation. So what I'm going to do is I've created a triangle here that we can kind of move around, or we could even change its shape. It doesn't much matter. Here are its three coordinates. Now, what we want to watch are the coordinate values for the different things we're going to do with this. So the first thing we'll do is let's reflect it across the y-axis. So I'm going to select my point, my triangle. I've selected my line, and I would like to reflect that across that line. Now, when I do that, obviously I get my points and nicely named by the primes. Let's do a quick measurement of D prime, E prime, and C prime, and see what we notice about the coordinates. So let's take a look here. We have D prime, E prime, and C prime there. If you look closely at their partners, it seems like only one thing has taken place, is that when we reflected over the y-axis, the x changed. And I think that makes sense. Now we could even change, the shape and the form. We could say, well, what happens if it was here, or what happens if it was across the line, and so on. But we still notice the exact same thing. The x values, if they were negative, became positive. If they were positive, became negative. And so there is a summary rule for this, that when we reflect across the y-axis, this becomes our rule right here, that we get x comma y equals negative x comma negative y. Write that rule down. That is a huge shortcut to the actual process of doing this. All right, let's look at the second rule. Let's find out, and I think you know what to expect, if we were to reflect it across the x-axis and we were reflecting the triangle DEC. Let's reflect over that axis. Now, you know that this is what we would expect to see, but part of what we want is when we look at these guys, let's take again a close look at D, E prime, C prime. Let's do a quick measurement of their coordinates. And again, let's match them up and take a close look at see how things have changed or are the same. What we notice looking at these coordinates is that the values that once were positive became negative. Now, maybe I need to create it where some of my point values are in the negatives, like this. And you notice that the negative y became a positive y, and so on. And so it does what we can expect it to. Maybe if the original was all in the negatives for y values, there are the negative y values, they all became positive y values. In other words, you know what that means, don't you? That the rule for reflection across the x-axis is a change in the y. Make sure you write that guy down. Next, we're going to reflect over a very unique line. This is the y equals x line. It says f of x, but this is just y equals x line. What I want you to notice is that it currently has all of the points where y equals x, 3 comma 3, 4 comma 4, 5 comma 5, negative 2, negative 2. It's y equals x because every y value equals the x value, and every x value equals the y. So we're going to reflect across it. So let's double click on that. So it's our line of reflection. Let's do our reflection across that line. There are our new values, our primes. Let's do a quick measurement of D prime, E prime, C prime. Let's measure those coordinates. And let's compare. So here's D, and here's D prime. Here's E, and here's E prime. Here's C, and here is C prime. Oh my goodness, how cool is that? You see what has happened? That whatever the x value was or the y value, they swap, they switch. So let's just do somebody new. And actually, I want a new color on this guy. Just I like having my image be something different there. So, anyways, let's just change some points here and just see kind of what happens to us here, like this. And yep, they're still swapping. What happens if we cross that line? We got some sort of funky reflection going on there. Exactly the same thing happens. What a cool situation. So when you reflect across the y equals x line, you get a switching of the variables. And when you do that, you will be reflecting across the y equals x line. Those three rules for reflection need to be memorized. It makes your life way easier. The next ones also need to be memorized. These will be about rotations. So here's our original guy, and we're going to rotate positive 90, which moves in a counterclockwise direction. So let's select the center of rotation as the origin. Let's select our triangle. Let's go do a rotation of 90 degrees. Yep, that's our guy, 90 degrees. And it lands right there. Let's give it a new color, right? Something fun like purple. Now, let's do a quick assessment of the new coordinates. Now, you're glad that we're doing it this way because these guys aren't that simple to see what's happening here. Let's put it up. Here's D. Here's D prime. Here's E. Here's E prime. Here's C. Here's C prime. You know what? Why don't we make these a little bit larger? Um, Well, we'll worry about that in a minute. Okay, so whoa, do you see what's happening here? I have a 3, and then in the back became a 3. I have an x that's a 7, and the y value is the 7, the 6. Notice the 6 that was my y became my new x, and it's a negative. The old switcheroo, and we are negating. Now, what would happen if we started with a little bit of negative numbers? Let's do that too, just in case, right? So we can see what's happening. So take a close look at D. What we're going to do here is we are taking the negative 3, that's the x value. It always becomes the y. The 8 that was our y value is negated and brought to the front. That happened in all of these cases. And so the 90 rule is right here. What a cool rule. So what it does is it takes the original xy, switches their place, and negates that y value that's becoming the new x value. Super, super cool. All right, now that we're done the 90 rule, you know what's next, the 180 rule. So we have our triangle here. We should mark out our center of rotation. Let's select our guy here. And let's go to transform and rotate. This time we want to go 180 degrees. And here it is over here. Let's do a quick little color change to see image, pre-image. Let's do a brown or something. Let's make this a little smaller so he fits on our screen. There he is. And we have some positive, some negative. Good. Let's do a check on the coordinates. How did these coordinates change when we rotated by 180? And so we can do a quick check there. And did you notice I made things bigger? Yay, I'm getting a little bit better at this. And you see that rule. You don't need me to do much here. Let's change our original around a little bit, move it around, but you can see what's happening no matter what's happening. We are just negating the x and negating the y, and it would be true no matter what. So that rule for 180, super easy to remember. It's just negative of x and negative of y. Well, we're done 90. We're done 180. Here we go. Let's take a look at 270. All right, 270 degrees. Here's our original guy. We want to rotate by 270. Whoa, way over here into this quadrant. And again, that doesn't matter about the quadrant because it depends where everything else started. But let's do a quick color change. Let's do something bright like this. And as always, let's do a quick measurement of D prime, E prime, C prime to see how they move. Let's measure those coordinates. Now, oh man, I love these rules. They're so simple and they summarize everything. Can you see what's happening here? Let's take a close look at these guys. So again, we're switching them, but this time we're negating the original x value becoming the new y value. This is a lot like the 90 rule, but just a little bit switched, right? You see how what's happening is that back term is becoming negating. So the 270 rule, there it is, right? It's switching the variables and it's the negative in that back term, that new y term. Write that one down. It's really important. Now we've done 90, we've done 180, we've done 270. We're not going to do 360 because I think you know what that does. But what happens if it was like negative 90? So let's take a look at a rotation of negative 90. I'm going to leave this thing here. Let's do a quick delete of this. And let's just keep rolling the tape. So here we are. Let's pick this. Let's go in here. Let's do a rotation of not 270, but negative 90. Wait a minute. It ended up over here again. Is that right? Did I type that incorrect? Of course that's there correctly. Let's do a quick measurement of our coordinates. Let's grab those, measure coordinates. Here they are. And guess what? It's the same rule as our friend right here. But you actually, now that you think about it, you actually know that. Is that going negative 90 is the same as going positive 270. The same would be true about going 90 and negative 270. The rule for 180 doesn't matter because it is the rule for 180, right? So those are the magic rules. Let's bring them up just one last time. So here are the 7 rules that we just discussed. And I'm going to be honest with you. You need to write them down and memorize them. This will make a lot of work ahead way easier. You don't have to plot points, count lines, nothing like that. You can just use the rule. Some of these rules we've already talked about and understand that if you want to go across the y, it's going to change the x because the idea is that you have a vertical line and whatever your x coordinate is over here, when you go to the other side, you get this one over here. This also makes sense here because if I had a line of reflection here and I reflect across that line to the other side, the only value that's changing is the y. This guy was that cool diagonal one, which if you're over here and you reflect across it, what happens actually is the y and the x values switch. I love that rule. Now, rotation is harder to kind of visualize as to why that was taking place, but you can see a pattern here for sure where you get the switching of that variable and then the negation of that value. I think doing something by 180 isn't that bad to remember. It's like going the opposite direction. So if you were like over here, then a rotation gets you going the exact opposite direction, right? So it makes sense that these are just negating the x and the y. You can see there's some similarity between these two, but there is definitely one important difference, right, as to who gets the negative. And I think you understand that these two are equivalent motions in the plane, so of course their rules match. Let me show you one more thing, maybe to help you to memorize these. What I want to do is help you to memorize these 3 rules. And what I'm going to tell you actually is that you might only have to memorize this one. Let me tell you why. So here's our original point right here. And if we rotate by the 90 degrees, what we learn is that it negates this and switches the value. right? So that is a 90-degree situation. Now, I'm going to use the 90 rule one more time. So to get to 180, I'm going to use the 90 rule. Now, what does the 90 rule says? Says switch them. Yeah, I can do that. And it says negate the new x term. So that would be this process. So again, if I did another 90 turn, this is what would happen to the points. And guess what? I just made the 180 rule. Now, if I want to get to the 270 rule, let's use the 90 rule when we're here. So that would be to move this guy to the front and make it positive. Yeah, okay. That would be move this guy to the back and make it negative. Yeah, and that's the 270 rule. So I'm actually using the 90 rule 3 times. Now, just for the sake of it, let's use the 90 rule one more time. What does the 90 rule say? Take that back term, negate it, bring it to the front. Take this term, take it to the back. And guess what? After doing that a couple of times, we've come all the way back to our original point. So what I'm kind of telling you, at least I tried, is that this guy actually can get you the other ones if you want to, because how do I get to 180? I just do 2 of the 90s. How do I get to 270? I do 3 of the 90s and so on. So good luck with this. Enjoy these rules.